Hey, hey, hey. Happy Friday, everybody. It is Friday, January 8th, 2021. I'm Brandon, host of Brandon's Show. Tonight is Friday, so we've got Friendly Fire Friday. Brian Leakey should be in to defend his crown from last week. And that'll be fun. We'll do that later in the show. We've got Critical Think here to start off with. And he's going to talk about perspective. I don't know. It's usually pretty interesting when Critical Think is in. We'll see how many pages of his presentation he can get through. I think last time we only got through 2 or 3, so we'll see where that goes. I see some people in chat. Ian Adams, champion the underdog. Am I pixelated? Uh-oh. Can you hear me though? Oh, it is too. It's pixelating bad. Well, we might as well nip this in the butt and see if we can fix it right off the bat, huh? I know that they were doing some, I don't know, maintenance in the area. My internet went out earlier, so I don't know what is with this internet problems. It's like they're upgrading a bunch of stuff in the neighborhood. I have no idea, but I'm gonna duck out for 1 second, bring OBS back up so we can start the show off good. Okay, there we go. I am reconnected right now. Hopefully that's better. I see a nice strong signal coming through. Hope you guys can hear me well. You should be able to. I see no signs you can't. Thank you for letting me know that, champion the underdog. Appreciate it. Let's see who we've got in chat. Gadget Inspector, Flat for Life, Ian Adams, Gary Wybinga, Super Flurf. What's up, Paige? Enigma, Gadget Inspector, Alexander Lightwater, and the Plain Truth, Anthony Burrows, Squirrel Sniper, and Mark Mikulowski. What's up, guys? Hope everything's going good out there. And I see the signal that it is looking good now. Good. And we don't have to worry about that later on down the road. So hopefully you guys could hear me earlier. We got Friendly Fire Friday, and we've got Critical Think to start off the show. So I'm going to head right in there because he is ready to go. See what he's got and go from there. What's up, guys? We are live now.
What up?
G'day, g'day.
What up? We got Critical Think. How's it going, Critical Think?
Yes, not too bad for a Saturday. It's Saturday here. We're in lockdown here for 3 days, so we're not allowed to leave the house anyway. Here I am.
Oh, just for 3 days. That's kind of weird. What can they get done in 3 days?
Well, they think that they can trace the sources in 3 days. As it turns out, it may extend, of course, but right now they want to put a halt to everybody's movements so that they can track this latest infection that arrived.
Okay. Huh. Interesting. Well, at least you got an excuse to sit on the couch all weekend and watch TV. And
I got yeah,
there you go.
I've got plenty to do.
We got Travis. What's up, Travis?
Hello, what up?
On the road. Travis is on the road. Jeremy, what's going on, man?
What's up? You know how I do. I stay flexing on them.
Yeah. Been listening in to you guys on Gems, having fun all afternoon. SC Montreal was over there just brawling with those guys. I think he would have brawled in real life, thrown fists if he could.
It gets heated. That's the Lions Den right there. You know, it's the front lines for us.
Right. Well, tonight, guys, we've got Friendly Fire Friday. That's going to happen a little later when more people come in. But to start the show off, Critical Think has a presentation. I don't know if it's a continuation of the presentation before, or you got something new for us, Critical.
Oh, it's more or less a continuation to try and sort out some of the points of disagreement.
Okay. All right. Whenever you're ready.
So I've got my screen up. You can let me know when you're...
Yep, I see it. Oh, something just happened. Can you guys still hear me?
I hear you.
I think we lost your screen, Critical Think.
Yeah,
Screen.
something happened here.
Okay,
No, I'll try it again.
sounds good. There we go. See it popping back up. I got the dancing squares here. And now I see the presentation and I'm ready.
Okay. So it all pretty much started with this. I've taken my auto level and taken a picture through the auto level. The sun is below eye level, which is a bit of a problem for flat Earth. And then it went on to talking about perspective, and that you claim that this is a perspective effect. And then we went on to about eye level. Something at eye level remains at eye level and doesn't dip down. There's a point of disagreement. And the other thing is that I noticed that the old horizon should appear to rise to eye level on a flat Earth.
Now,
It gets a bit of,
can I stop?
Yeah,
Do you want
so-
to go through your presentation or do you want me to wait until you get through your slides and then respond? Because I have a point of contention already, of course, which I guess is what you're addressing.
I have 3.
I've heard your points of contention,
Mm-hmm.
and you illustrated them on a show previously, so I want to address that.
Go forward then.
Right, so you basically were saying that in the orthogonal view, there's always a gap between the ground and the line of sight, which is true, and you couldn't work out how there would be a gap, how there would not be a gap when you got to the horizon. So I'm going to try and deal with that here with this. So what the picture I've got here now is a flat space, right? Let's just assume that there's no refraction. It's just flat. And there I have 3 stakes in the ground. And I'm looking at the stakes and I'm just going to say, all right, there's 6 foot, 6 something, doesn't matter. It could be 6 meters, but let's just say there's 6 foot. Now I can sight along the top of those 3 stakes. That sight line will never go down. It's at my eye level, but that's not one of the primary things I'll be addressing today. The thing I want to address today is perspective and orthogonal view. So there is only one reality, and perspective is not a different reality. You're in what you call a perspective view. It still describes one reality, and this one reality is illustrated through an orthogonal view. And I can convert between perspective and orthogonal, and I'm going to show you how it's done. So these sticks in the ground, if I'm going to have my eye at that camera, or in this case it's an auto level or a camera, if I look to the ground at the first stick at point A, that's about an angle of 45 degrees. I'm looking down. If I look to the bottom of B, that's going to be a little bit less. It's about 13 degrees, I think. And then C is a higher angle. So this is why the ground appears to rise. It's because I'm looking down for the first one, I'm looking up a little bit more, and then up a little bit more.
That is not what your diagram shows. And to be honest with that, this diagram does not show the ground appearing to rise up to camera level. It shows the physical Euclidean reality of the situation.
It does show the ground rising to eye level, and I'll try to explain it again. Can you
No, I understand your explanation. I am pointing out that this does not show the ground rising to eye level. That blue line that you have up there will never meet the line below it because they're parallels. And as we know in Euclidean geometry, parallel lines don't converge. nor do they appear to converge, because it's not about appearance, it's about physical reality.
Well, when you're looking out to the horizon, it's all about appearance. Okay?
Yes,
I agree with that 100%.
Right.
So here's what I would have. I'm sorry, just real quick, since we paused anyways. What I would have done myself now is I would have set up these three posts out at particular distances and then taken a picture and then drawn your lines there, because we're going to see in perspective, because right now we're looking orthogonally. So I'm just saying.
Yeah, I have done that in other places, but today I'm just explaining the concepts. And I can go out and take pictures and map all this out like this. It will all, the physical reality will agree with what I'm saying here. Now, and there's plans to do something like that as an experiment in the future. But right now, how can the ground only appears to rise up? It does not actually rise up.
Correct.
And the reason why...
And what you're measuring with side angles is how the ground appears.
So say that again.
What you're measuring when you take a site angle measurement is how it appears.
That's correct.
Uh-huh.
So if I look at point A, that appears down there at 45 degrees. When I look at point B, it then appears higher because I've got to lift my sight, where I'm looking. So that will appear higher. If your observer is there to the left, it will appear higher. So that's, as you go further away, it appears, the bottom of those things appear higher and higher, but I'm still looking across the top of each and every one of them. Is that clear?
Yeah, that would happen in, you would lift your camera from A to C at a different angle in either one. If you drew in this diagram, if you drew the ground appearing to slant up, you would still have those angles.
No, you won't. And I'm not moving my camera in this case, right? My camera's staying...
You don't need to draw the ground appearing to rise up. He's drawn it as a flat earth. He is literally drawing a flat earth right there.
Oh, I understand that, but that's not what's at contention. Correct. But yeah, I don't think you understand what I'm saying, but go ahead anyway, and we can circle back to it.
No, tell me again, because this is pretty fundamental to the way we look at things.
Exactly. Yeah, it's very fundamental. This will make all the difference in the world between thinking that the earth is flat and thinking it is a ball.
Critical, why aren't they drawn on a curved line? Why have you drawn them on a flat earth?
This is just a illustration of
demonstration
how
of
works.
Reality.
No,
just on a flat surface.
All right, let me
just how a flat surface should work.
Okay, let me share my screen with you real quick. This is what I'm saying. I'm just pointing out that this would be the same. I'm going to stop watching yours for a second, and I will share mine. 1 second here. Okay. Here's your diagram, right? You've got these angles to A, B, and C, but you've drawn a Euclidean diagram, right? So your angles to how it would appear, let's say we showed the Earth just for the, shits and giggles, okay? Let's say we showed the Earth rising up, appearing to rise to eye level. And we'll say this is looking a really long way, okay? You see those angles are all the same. You'd still have to tilt your camera up. So I'm just pointing out that you said I would have to tilt my camera up because I'm pointing at these positions along the ground, you're still going to have to tilt your angle up if you were to draw it in perspective. Like this. If you were to
All
draw the ground as it appears to rise.
No, I really do disagree wholeheartedly with drawing that slope line there. That's an incorrect way to draw it, but I know you like to do it that way, but just listen to my explanation first, right?
Can
There's
you
no
acknowledge
need to
the
draw
point
it
that I just
slope.
made, though, that you would have to still tilt your camera up?
No, I'm not tilting my camera, okay? This is just a line of sight. If I've got a view through my camera, if I'm a person standing on the ground, my eyesight is, if I look at the point A, I have to look down. If I look at point B, I'm looking up a bit more. The angle is what changes, which makes it appear to rise. That's the point I'm trying to make. It's not actually rising. It appears to rise because even if I take a photo at that point, even without moving the camera, A will be lower than B, will be lower than C.
That'll be in both cases. What you just said is true in both cases.
I know, but in my case, I can, those angles in the angles and sizes, if you draw that line slopey like that, the angles and sizes do not match reality. The way I draw it now, I can draw this. If I draw this to scale, those angles and those relative sizes will match reality.
Can
right?
you
The
show me
angles
that
in
over a
particular.
10-mile
has
distance
he done
over
it?
a long, no, hold on,
Yeah.
hold on. Can you show that to me over like a 10-mile span that holds true for long distances? Because short distances, you can see, like, if I tilted this down real low like that, and, you know, way out there, this line would come up to meet or appear to meet the line of vision. The difference between these two, here, let me just tilt that up so I can make my point with an illustration. I'll just tilt
How
it a
do I
little bit.
see
Do you
your
see how
screen?
the difference between these two is not very much, and it increases with distance? Now, this line, since it is at an angle, right? Well, let's make it at an angle. Since this line is at an angle, eventually, when you get way out there to where you know the horizon is, or where the horizon appears to be, that's going to be a lot of error. But up close, this is pretty damn good, right? This isn't that bad. So and what I need is some experimental evidence. I need more than you just drawing diagrams and saying this is how it should be, because you've already said that the angles would slope up, and I showed you how that's true in both models. And I've showed you how the error would compound over distance, and that's what I need disproven, critical, because I understand both hypotheses. I understand them both, but I need experimental evidence to prove it, not just we live on a ball, therefore this is why we do it this way.
The thing is, the experimental evidence can be obtained very easily, but I can understand what will happen if somebody does do this experiment. It'll be just poo-pooed anyway. But the thing is here, if I were
So
to
you're going to decide what we're going to do before an experiment's been done or anything. You're going to decide what our reaction will be. Gee, that's
I don't
really...
have to decide. I already know that the way you've reacted in the past is going to be projected into the future.
All right.
So
well, that's kind of a poor attitude to go into it with, but I'm going to tell you, critical, that we are not, at least I'm not in the business of just taking people's words for this kind of thing. I need harder evidence. I have personally a higher standard of evidence than just drawing a diagram and saying this is how it works and calculating it and saying this is how it works, because I don't trust the people who have told me this information. So
what I'm trying to say is, if I put 3 sticks in the ground, 6, 6, 6, and I'm just going to go under this a little bit more.
Are you sharing? Go ahead.
Wait a minute. Wait a minute.
Can I interject and ask Critical Think?
No, wait a minute.
just a-
Wait a minute. So, if I were to actually build this, and I have done a little bit of experimentation like this before, and this is how surveying works anyway. So this is what every surveyor does.
Oh, no,
They-
hold
they
on.
throw-
Stop right there. Stop right there. You just said this is what every surveyor does. So this is what geodetic surveyors do?
Yes.
Well, no, they don't just measure like this with the site angles and that's it. That's not what they do.
I'm not. All right. Let's not divert.
Well, no,
Right,
stop
let's
saying
just-
stuff that's not accurate then, and I won't have to stop you and
Well, it is
clarify.
a surveyor uses a theodolite to measure angles.
This is for
Now, you're
planar
just
surveying,
trying to-
correct?
No, a geodetic
So
surveyor.
this is how
I don't
geodetic
know what
surveying,
they
then where's
do
the
in
calculations
plane
that add on
surveying.
the earth curve, Critical?
No, I'm not talking about earth curve here. I'm just talking about flat right here. I'm saying that
We're
when
not
you measure
talking
an
about
angle,
earth curve,
wait a
of
minute.
course
Can I
not.
talk, please? Can I talk? When you measure, you can measure angles with a theodolite. Now, I could get a theodolite. I could find a small piece of, a 100-foot piece of ground that's flat. I could put 3 stakes in the ground. I could measure these angles here, and they would match exactly what my scale diagram shows.
Well, 100 feet is not going to be enough. So what's the limit that you can use planar surveying without adding curvature calculations and anything else? What is the limit that you can use these tools and this straight Euclidean methodology and still be accurate without having to worry about curvature?
Well, if you worry about I think the order of 200 meters is you start to get curvature affecting your result. So it's not going to be flat. It's going to be a few millimeters out over 200 meters.
Exactly. So at that point, then the error starts to get introduced into the calculation where you will add the curvature and you'll say, see, this all works out with this curvature math. And what I'm asking you to do is to validate that curvature math via experimentation. So anything under that 200 meters, and that's even too short because of margins of error, isn't going to do me any good. That's not providing the evidence that's required in order to validate this for long distance observations.
All right. The thing is, the distance on a flat plane, the distance is not going to matter. You're not going to see anything different on those angles. It doesn't matter. See, I've got here
Rubbish.
626.
So the ground being
Yes,
sloped
not
away from
down
you
to-
in all directions doesn't matter on the two models. You're going to see the same thing.
On the two models, it's obviously going to be different, but I'm talking flat right now.
Okay.
On a flat surface, right? If I've put 666 there, this could be 6 miles high and 20 miles apart. There's nothing going to change the way light travels there.
Great. So
Other
show
than
me the
refraction, which
experimental
we'll
evidence to
ignore.
validate that claim that you just made. That's what I've been asking you
Well,
for.
it's a fundamental property of straight
So
lines.
says you.
right?
So if it's so fundamental, where is
Then
the
prove it.
experimental
Yeah, it's so
evidence
easy,
to
prove
show
it.
that this
No,
holds true over long distances? Because you don't use this method for long distances. You just told me you don't use this method for anything more than 200 meters, which I believe is further than a planar surveyor will use this
you
tool.
asked me a question. I answered it. It's not. I am not trying to make this measurement right now. But if I were to try and make this measurement, I would limit it to less than 200 meters because I don't want curvature to spoil my measurements.
There we go. We don't have any disagreement then. What's the problem?
So the problem is that people say that if the light is traveling along these lines here, that it should do something different the further distance you get away.
Well, of course it
that's
does.
not the case.
Well, prove it.
No, well,
Prove
how do you
it.
prove that? How do you prove
That's
that it
what I'm
does?
asking
Because
you.
I've just
You said it's
no.
fundamental. What proof do you have?
I've drawn the diagram. The light travels in a straight line.
I've
Now,
drawn the
wait a minute,
diagram,
wait a
therefore the
minute,
light
wait
travels
a
in a
minute,
straight line.
Wait a minute. We are ignoring refraction for now.
Are we?
Right?
Okay.
Light, in the absence of refraction, light travels in a straight line. If this is 6, 6 and 6, the straight line join those 3 points. Does somebody want to say that makes a curve now?
No, we're not talking about refraction. Go ahead. Go on with your thing here.
So nobody answered my question. Are you saying that line?
But all those sticks are the
intersecting
same
those-
size, even
So-
though one's way further away. So he's put no angular size in there or anything. This is not perspective at all.
Well, that's what I'm.
We haven't
That's
got
what
to
I'm
the
getting at. I'm
perspective
asking
part.
him to validate that this method can be used at longer distances than planar surveyors use it for, because this is how you assert that there's Earth curvature. For those distances, you say, well, it's dropped. Well, like your sun picture, you say, well, the sun is lower than my camera site. Therefore, the Earth is a ball, and here's my calculation that I add to make all the math work out. I want you to validate the mathematics critical.
Let's validate this right here and now.
We can't.
This
but go ahead.
stick is 6. No, wait. Let me ask my question,
Sure.
and I want an answer.
All right.
These 6, 6, and 6. There's 3 sticks. They're 6, 6, and 6 high, whatever they could be. 6 feet, 6 meters. Is the line that joins them, the top of those 3, is that a straight line?
You know, in physical Euclidean reality, it's a straight line. Yeah.
Yeah, you're asking
What
physically
about-
or in perspective?
In either, is that a straight line?
Well, they're different. One
In physical
is-
reality, is that
in
a straight
physical
line?
reality,
Oh.
they are all the same height. The line will be straight. But when you look at it, because the one at the end is furthest away, it will appear to not be. It will go down. The line will go down towards the last one.
No, it won't.
Oh, well, then
How
that's
can a
okay.
straight- how
Provide
can
the
you-
experimental
straight line
evidence
will
that
be lower.
validates that assumption. You've
That's not an
asserted it
assumption. That's just
and
if
told
you,
me
if
that
you
you can't do
cannot
it because of
agree.
Earth curve.
No. If you cannot agree that a straight line is a straight line, there's no point.
In
What's
physical
the point of
reality,
having
a straight
any
line is a
discussion?
straight line. Of
Lines that are
course,
curving
don't straw man
straight
what I
lines.
said.
Fucking hell.
So ask that question again, Brandon.
Well, I didn't ask a question. I at least not just then. I said, yes, in physical reality, a straight line is a straight line. No one is arguing that a straight line isn't a straight line in physical Euclidean reality.
So why can't you look at a straight line and see it as straight?
Because of perspectives.
we see
Prove
in
that you can.
perspective.
Hold on. Prove that you can over long distance critical. We're asking you to prove your methodology with experimental evidence. That's all. You could be right.
No,
Please. Yes, pretty please.
wait a minute. A straight line is a straight line. When you look down at it straight, why don't you try to prove to me that it's different?
Okay, wait. I'm lost real quick. You just, before your last question right then, critical, you said, if a straight line is a straight line, why isn't it straight when you look at it? Right? Did you ask that question?
Yes, I think that was it.
Okay, great. I don't understand your question. Honestly, I don't. I can't picture what you're asking. So if it's okay, can you, if not, show me what you mean? Try to explain. I don't know what that means.
If I have a stick that's 6 foot long and I look down the stick, is it curved or straight?
Are you talking about like if you're looking at a pool cue and you're looking to see if it's, is that what you're saying? You're looking at it that way? Is that what you mean?
There's something like a pool cue. Is it curved or straight when you look at it from the end?
Depends on how accurate the cut is, I guess.
I've said it's straight. It's straight. So when you look at it, do you see it as curved or straight?
Okay, this is conceptual, so it's straight. Okay.
It looks straight because it is straight. Is that correct?
Sure, I'm okay with this so far. Yeah.
Get us to say yes to a couple of fucking questions a fucking dodo bird would say yes to, and then say something crazy. Do it.
Hey, I'm not a dodo bird.
He's looking at
I
the
am.
pool cue end on, but he's looking at these straight lines side on.
No, if I were to go to an end-on position and look at that straight line, look straight down it, would it appear straight or curved?
Say that one more time.
Well, the last little stick will be dropped down in your line of sight because it's
That's
further
not what
away.
I asked. Just first of all, I am looking straight down that straight line at the top. It's a straight line.
Yes,
I'm looking down it. Is it straight or curved?
From what I can tell, we see in straight lines, straight perspective lines, having no relation to being parallel to the Earth or parallel to each other. We see straight lines. Not if something is straight in reality, it's going to look like a straight line. When you look at it, it's not going to curve. It's not going to look like a curve.
You're just trying to dismiss the perspective in this and say that that stick at the far end is the same height as stick A or B.
Yep.
And that's
Thank
nonsense.
you. Yep.
And you know it's a con and bull, and you're just trying to get us to say, yeah, a straight line from stick to stick to stick. Is it? Yeah, it's a straight line. Well, then now
Yeah,
I'm going
that's
to
what
say
he's
the rest of this
doing,
bullshit.
yeah.
You agreed with me. Now you can all eat this. Quit playing that game. Get to a point. This is bullshit.
So are you saying the straight line is curved or is it still straight?
Holy fuck, dude! Get on to the next point. Jimbo's right.
No.
No,
You're
we're not
trying to
playing
bring
this
perspective
Socratic game.
to it.
Get to the point.
This is my point. A straight line is a straight line. It's not curved. No,
Yeah,
I
it will
don't
be
care
straight.
what.
How many times do
perspective you
I
want
just
to-
answered
It
that
won't be
at length? Go ahead. Continue.
Right. So now people have been saying that because of perspective, the third stick will appear smaller.
Yes.
Right?
Yes.
Right.
No duh.
But this straight line is still the straight line. The top of the stick is still at the same place. In terms of if I'm looking at the top, the ground
No,
comes
But
up
no,
here
hold
to
on.
rise
But
up.
it is
will
no
be-
longer parallel in your vision to the orange line on the floor, correct?
Exactly. Well,
It is parallel. The bottom, the floor, the ground appears to rise up because of the reasons A, B, and C angles start to get less and less. And then that's what makes it appear to rise up.
Yeah.
no,
So
perspective makes it appear to rise up.
what's your
Well, that
point?
is perspective.
You're retreading what we've already gone over.
Yeah, but I'm just making sure we have a point of agreement now
What have I agreed to, do you think?
that a straight line is straight when you look at it from the end on.
But it might not be the same height in perspective at the last one as it is at the first one.
Well, let's see where he's going with this page. I
Sure.
tentatively agree because that is not very specific, but go ahead.
Yeah, it's still a straight line,
Yeah.
but the way you see it changes it. That's
Okay,
why
so
we're trying
can
to
I-
explain
Just-
to them that geometry is different.
No,
Orthographical view is
what-
totally different to perspective view because they do two totally different things.
They
Yes.
all
Let me-
describe the same reality. There is only one reality, an orthogonal view.
No, because there's the
Is it-
Euclidean reality of actual physical Earth, and then there's the way we see it. So there's actually two different things going on.
There really is.
Okay,
They're
let me-
not
actually
the same at
seeing-
all. There's different rules for
They're
each one.
not
And
the
what we're
same.
measuring when we
Can I
go
jump
do
in?
sight angles
Totally
is what we
different
see
rules.
critical.
Because
Travis, let Travis go ahead.
In Euclidean, in Euclidean, parallel lines can't intersect, but in perspective, train tracks, they do. So it's two totally different things. Thank you.
All right, so just real quick, it just clicked because I've been looking at this right now. I'm looking through an aisle of 53-foot truck containers. Okay, so right now I can see that the side facing me is perpendicular to the ground. And I can see the side of it going into the distance, and even though the top is parallel to the bottom, visually the top is dropping down and getting closer to the bottom. They're both in perspective now dropping. So even though it's a straight line, it's no longer level in my vision.
So That's correct. Anything at eye level does not drop and does not go higher, though. Above eye level, it drops. Below eye level, it rises.
Yeah,
Does
but we
anybody
know
want to
this.
disagree with that?
Well,
Yeah, we know this.
here's what I'm saying. I don't necessarily disagree with that. However, I want to see it validated for long distances. You have two major assumptions here. Your first major assumption is that the ground will always appear to rise to eye level on a flat plane, no matter how far away you're looking. I don't know what you base that on, because I don't know how you.
We're getting to that. We're getting to that. But it's
No,
not,
listen to me.
no matter how
Do you have
far you're looking.
experimental evidence that you base that on?
To answer that, yes.
No, of
No,
course
you
he
don't.
doesn't.
But not, the thing
He'd be
is,
showing it if he did.
the thing is, you cannot find a 10-mile stretch that is guaranteed to be flat, right?
I have.
Because there's Earth
There's
curve.
lots of them.
Now-
Come on, buddy.
Now, let
We've
me.
got heaps
This,
of the Bolivian salt flats. We've got oceans, lakes, canals. What the hell are you talking about?
Yeah. Okay. Hold on. Just real quick. Yeah. I've been trying to hold my tongue. Okay. Critical. You just inserted curve without any demonstrable evidence. Okay. So no, I have got a 20-mile shot to the Anacapa Island. That's flat, straight and level. Okay. Minus the waves. Okay. My toes in the water on Emma Wood State Beach. If you were at the island and had your toes in the water, we are level to each. We are horizontal. We are parallel. Okay, so yeah, we do have those kinds of stretches of land or water. Yes, we do.
Lots
have
and
you
lots
measured it?
and
Have
lots.
you actually measured it as flat? I'm going to ask that question.
Yes,
Okay.
things that have frozen over been measured. Yes, we have measured them.
Right.
Okay. Listen, just real
That's wrong.
again.
We'll
This
go on.
okay. Yeah, I have not personally measured the distance. Okay, because it's a conceptual idea over with something so large as 20 miles. Okay, but you have to understand the argument by equivocation. That is that water maintains a level surface when contained, right? So that if a teacup you measure from edge to edge, that's going to give you a level surface of water. You make it bigger in a sink, you make it bigger in a bathtub, you make it bigger in a pool. It's all by implication and inference based on the physics of water. So water does not ever demonstrate to us that it has a curved surface when it is undisturbed. Otherwise, if it is disturbed, it's just wave undulations. It's not curvature. So
I feel that you're trying to divert to a different topic,
Well,
and I'd
you-
like to stay on
no,
topic.
stop. I got this. No, stop. You said we don't have any level surfaces over which to make these observations. And then you said because there's curvature. But you're inserting curve. Now, I am just simply taking it away. No, there's
All right.
not. There's no curve between
Before we go,
me-
can you just stop with that just for the moment? Because if you are trying to determine is a 10-mile stretch flat and straight and flat or curved,
There's
you
nothing
cannot-
to indicate that it's
excuse me,
curved.
can I finish? There is if you are trying to determine with a bit of science whether it's flat or curved, you cannot assume that it's flat.
That's not science, it's math.
And you can't assume that it's curved either.
Yes,
That's why.
I actually
That's
can.
why
can
we're doing
I
assume it's
these
just
flat.
told
measurements.
If it's
you.
over
I just
water,
told you how.
Yes, we can.
Yes, we can assume that it's flat because
No, you
we
cannot.
can. Okay,
Yes,
listen.
we
Listen very
can.
carefully, Pete. Hold on. Listen very carefully. Okay, when we understand that water that is contained maintains the same elevation at its borders, it doesn't matter how big you make it. Simply because, okay, look, if I have a smaller pond that's 1 acre, and I walk around that pond with my foot in the water every single time, I'm at the same elevation every single step, because water doesn't exist at a different elevation unless it's flowing. Okay? Now, if I get to a bigger lake like Lake Michigan and I don't have the ability to walk the perimeter, I fucking know that the distant shoreline is on the same horizontal parallel elevation. I don't have to assume anything.
So you understand how elevation works on a globe. Do you understand that?
Okay, listen, we don't live on a globe.
Wait
We
a
don't
minute.
live on a globe.
We're just
Wait a
talking
minute.
about
Answer
Hold
the
on,
reality,
I've got
question.
this.
Michael.
I've
Do
got
you
this. I've got this.
understand?
Paige, I've got
You,
this.
do
Hold
you,
on.
no. Do you
May I throw
understand
one
how
thing in there?
elevation
Hold
works?
on.
Go
Let
ahead.
me handle this very. Okay, look. You are imposing a construct that you have not proven.
It doesn't matter. Let's just say that my question is, do you know how elevation works on a globe?
It
I don't live on a
doesn't
globe.
matter.
So basically,
let's
you
just
can't, you
fantasize
don't
about all
know.
these things. It doesn't
So
I
matter.
why
know
are
what
you
you
trying
are-
to talk about stuff you know nothing about?
No.
Why?
I know. Listen, I know what you. Yeah, I can give you the answer that you want, but I'm not going to because we don't live on a globe. So stop bringing it in without verifying what you're claiming.
Stop bringing in flat Earth without verifying your
I
claim.
just told you how to do it.
I just told you that's invalid.
Water
Now-
verifies it. Rubbish. You would have to. You would
Okay.
have to falsify.
Right?
That
How
water
can you
is level and
falsify it?
horizontal.
How could you falsify it?
We've done that 1,000 times. Can we move on?
No, you haven't. You have
Yes,
used
I have.
perspective. No, you haven't. You haven't physically
Yes, I have.
demonstrated that water drops or humps. All you've done is take long distance pictures with tools that shouldn't be used for those kinds of things and asserted perspective.
Okay,
is
so
Earth curve.
why should the tool not be used for that kind of thing? Can you answer that?
I can answer that question.
Because it wasn't made
So
for the
you had
job
asked
of
me a
long
question
distance
about
like
A,
that.
B, and C. If you look down the top of those, is that true? And you've probably done this. If they're all at the same elevation, they're all level for 500 meters. Do the tops of A, B, and C all remain perfectly aligned in reality?
Yes.
On Earth, that happens. After 500 meters, the top of those will all be perfectly in line if you look down it in a straight line.
Not on a curved surface, no. This is on a flat surface.
But
I'm talking
see, there
about.
you go again. So how do you know? How have you validated that what your assumption is correct? Because you haven't done it in reality.
Because
You haven't seen it in reality, have you?
example. Let's just
You
go an
haven't
example.
seen
If
it in reality, have you? You
Yes,
always,
of course I
you've
have.
always
You can
seen them
set up.
drop down with distance,
demonstration?
and then you say it's Earth curvature.
That's not the case, okay?
That is the case. So you don't
If
assume Earth
this
curvature
works
for after
exactly
500
this-
meters?
Oh, come on. This works exactly the same over a short distance as a long distance. Light
Prove
does
it.
not change
It's
behavior,
not about light. Prove it.
right?
But perspective does.
We haven't even
We're not
finished the
saying light's doing
perspective
something
thing.
different because you don't know the difference.
All right, let's let him
right.
finish. Go ahead.
So,
Go ahead. We'll
so-
let you finish your presentation.
oh dear. Now I've just lost where I was at now. Just a minute. Let me regather my thoughts.
Sure
here.
thing. All right, let's all take a
Sorry.
deep breath and
Difficult.
get ready for the second half of this presentation here. Let me just give a shout out to Flat for Life, $10 super chat, or Streamlabs. Thanks, brother. Really appreciate it.
Right. So nobody answered the question yet. And we'll get to that after then about why you can't use an auto level over longer distances. So what's the reason for that?
I just told you that.
They're
So
not
and
made
I
for
just
that
told you that. So if
purpose.
you're trying to line up
No.
A, B, and C,
What was your answer? I missed it. What was your
okay.
answer?
What I said was, when you look down A, B, and C, and they're all level at the same elevation, you will not see them line up, will you?
Right, so that's because of Earth curve, and that's why you can't use the
That's
thing.
the problem right
more.
there, that you're assuming that's because of
Prove
Earth
that.
curve
No.
critical think. We want you to
Oh,
prove
just
it.
a minute. Yeah, sure, just a minute.
Oh, here comes something really special.
And we should add physically. Prove it in physical reality. Don't just give us a picture or a math equation. Show us at the water level it dropping lower at the point it's dropping, not from 27 kilometers away using an auto level. Like, show us actual physical demonstration of the water drop.
In the information about leveling, the curvature of the Earth means that line of sight that is horizontal at the instrument will be higher and higher above a spheroid at greater distances. This effect may be insignificant for some work at distance under 100 meters. And that's why when you're using it for leveling, you don't
Angular
use
size
it
does the
more.
same thing.
You don't use it for more than 100 meters. That's the reason. So you don't use it for long
No,
distance
because of angular
excuse me,
size.
can I finish my sentence? You don't
You're
use
speaking
it.
an absolute load of nonsense.
Can I
It's not because
finish
of
my
Earth
sentence?
curve.
Let him
please?
finish.
May I
We'll
finish my
never
sentence?
get through this page. We know it's rubbish. We'll respond in a minute.
So the published reason why you cannot use those auto levels for measuring leveling, for leveling the ground, you cannot use it over 100 or 200 meters because of Earth curve. So you can say
Yeah,
you don't.
they think they live
But
on
the
a ball
reason is
too.
because of Earth curve.
Well, I didn't think of that critical think. Oh shit! Now that you've told me that, I think everything that you said is true, and I no longer require experimental evidence that that's why they drop down at distance.
Yeah, me too. I'm feeling really dumb.
Aren't we all
right
feeling better
and
now that you
very
showed us in
humble.
Wikipedia where
How
it says there's
critical.
Earth curvature?
So you've never quoted anything from any website or anything?
I'm
not
not
see how
bagging on
silly
you
that is
for
critical.
using Wikipedia. I'm just saying, come on, you really think that is going to change our mind? Are you in this conversation with me? Because it doesn't seem like you're following along with what we're asking. I understand your
No, he's just
position
trying
that
to
those
tell
won't line
you.
up after distance because of Earth curvature. I'm asking you to validate that over long distance. And you can't do it. You say, well, I can't do it because of Earth curvature.
So the reason why we know that it's Earth curve because we know how these
You
instruments
don't
work.
know.
Well, why do you say that? Why do you say I don't
Because
know?
water is always level.
I'm not talking
and
about water. I'm
horizontal.
talking about this instrument. I know how this instrument works.
What does
I'm
the
not I don't
instrument
want to talk
do
about water
with the
because that's
fundamentals?
75% of the surface of Earth.
What does the
When we
instrument
stick
have
to
to
the
do with
topic-
the fundamentals of how we see and how our vision works compared to Euclidean
When
geometry?
I look through the
what
instrument
does that
and
have to
take
do
a
with it?
photo through the instrument, what am I taking a photo of?
Why are you doing that?
Why am I doing what?
Taking a photo with an auto level miles out. Why are you even doing that?
Do you know that because that instrument measures level? I want to measure level. I want to prove the shape of the Earth. That's why I'm doing it.
Well, actually, it doesn't measure level on your model because you say that it's a tangent
Level
to the
curves
surface of
around
your
the ball,
sphere.
yeah.
So it measures a straight line, supposedly, according to you, and then you add curvature.
No, you don't add curvature, right?
Really?
The straight line is
It'd be an
level
autocurvometer
to
if it
down.
was.
They
It would be an
hijack the perspective math
autocurvometer.
and use that.
It's an auto leveler, not an auto curvometer.
That's right. It measures level.
Not
It
an
doesn't
automatic
know about
curvometer.
curvature or no curvature. It's a
Or,
device that measures level.
So let me ask you something
So-
then. So you're looking out through the what is it called? The eyepiece in the auto level and lining these A, B, and C up, right?
If I were to do that on a flat surface, right?
Well, okay, I'm talking about in reality. So when you look through that and you look at A, B, C, would you line them up?
Yes. You
Yeah,
can't
would
line them
you?
up on over a great distance. B will be higher than A and C.
On both
What?
model. B will be what?
What?
On a curved surface,
A
B will be
Brandon.
higher.
Okay, because
Oh,
you're
holy
looking
shit, he's
from
doing the
A
Bisland
to
hump.
C, so
If
B
you were to
is
line them
higher.
up.
Okay.
If you were to line them up, if you were to measure level, B would be lower and C would be lower
Okay,
than
so
that.
then
But if
you're
you were
not
to line
measuring
the
level
top
with
up
this.
with
Oh
A
my
and
God, he's
C.
got
Then
a
you're not
drum, a
measuring
drop,
level at
and a
long
hump.
distance with this, are you?
Sorry, what?
Then you're not measuring level at long distances with this, then are you?
The instrument sights level no matter the distance, right? You don't use it at short distances because if you're trying to do surveying work or leveling work, Earth's curvature will
You
make it
don't use
inaccurate
it
over long
at short
distance.
distances.
So if
You
you
just said you don't use it at short distances.
if you
You mean you don't
pointed
use
this
it at
out
long?
1 kilometer and you said, okay, I'm going to point my instrument out 1 kilometer, I'll make sure it's level, and would the spot that it's looking at between your crosshairs be level with the position you're at?
It's level from where I'm standing. It's not level 1 kilometer away.
Oh,
it's
shit.
a different level 1 kilometer away because
So
the
you
Earth
see
is
a hump
curved.
in the middle in your mind.
There is no hump. From where I am, the Earth always curves down away. The only reason people say it's hump because they're not looking level when they see a hump.
You
Right?
said
If you look
if you
level,
look
it
from
is
A
not
to
a
C,
hump.
B will be up, meaning there must be a hump in
No,
the
no,
middle.
Can he
that's
measure
a
that?
sight line that's not level. Do you understand that?
So
On a
it
curved
doesn't
Can he
surface,
measure
measure
level
that?
sight
with
line
the
is
sight
not
line.
level.
So it doesn't measure level with the sight line then.
This, if I look, if I use my level instrument, right, it will sight level. It won't sight from A to C on a curved surface.
Ah, okay. So it will work. Maybe that's because we're on a flat surface.
I don't understand what you mean by it will
Listen, this
work.
is all nonsense. Do
We
you
know
have any
you
of the
don't
experimental
understand.
evidence that we've asked for, or some other argument that is going to change our minds about wanting that evidence?
We've shown you plenty of experimental evidence. You
Yeah.
don't accept it.
Like what?
And we want physical measurement, not optical measurement.
Yeah,
That's
like-
all we want.
Like that.
Physical
That's
measurement.
experimental.
No,
That's
that's-
physical.
The assumptions that we
No,
want you
it's
to
not. That's an
validate
optical
are
measurement.
included in your calculation here.
Sorry, what?
The assumptions that you the assumptions that we want you to validate, that we're asking you for the experimental evidence for, are included in your calculation here. This, you can't use the assumptions and use them to prove the assumptions.
What assumption? What?
Well, you look at this and you tell me the sun
That the
is
ground's
below
curved.
the line of sight, the yellow line, therefore Earth's a ball, right? Because you claim, you assume that can't
wait a
happen
minute.
on a flat
This
surface,
cannot
right?
happen on a flat Earth. This is what I've said. This cannot happen on a flat Earth.
Rubbish.
Yeah, what's your evidence
Rubbish.
for that? What's your experimental evidence that shows that this couldn't happen on a flat Earth?
Because how can something that's above that line there get you to see it at below it? How does that happen?
That's what we want you to validate over long distances, because
I
in
don't have to
reality,
validate. It's physically impossible.
Okay, hold on,
That's
just real quick. Listen,
that's
No,
just
it's
a fundamental
hold
thing.
on, just
saying
again,
that.
listen.
How can you say validate a fundamental property
critical, real quick.
if you can't say
Like
that
water
something that is
being level
above
and
something?
horizontal, a fundamental property.
Okay, critical.
Go for it, Travis.
Well, you're showing us the same photograph. I've asked you for numerous observations where you can show us the same setup with the same result. Okay, so let's say, for instance, you took that picture at 4:47 the day before. Take the next picture at 4:47 and show us the exact same result over the 4 seasons, right? I mean, that's what I've done, and I've gotten different levels. And I even have something I'm going to try to do this in the next 2 weeks when I get to California, is to do something different. But I can show you that I have set up in the same exact location, and I have different visuals every single time. The ground is higher, the ground is lower, the ground is closer to me, the horizontal is closer to me, the horizontal is farther away. I can show you that over and over and over again. You've given us one picture to hang your hat on, and when you first started this, I said, do you have any others? And you still you're still showing us the one. There's no
I don't have
control.
many. I have only about. I don't have any more pictures of the sun at that location because it's very difficult to capture that particular sun because we've almost always have clouds. But I do have other locations where I've got the sun below level, right? That's the important thing here. I know that the horizon will change a little bit because of the conditions on the day. But the sun, it's supposed to be 3,000 odd miles in the sky or whatever, but how can it get to be below level? It cannot.
Well, critical,
Okay.
if the horizon doesn't rise to eye level, if it's always a little bit below eye level, then as the sun moves further away, it will, if it needs to be going past where we see the horizon, then it will be below level, won't it?
Below what level?
It cannot. But I'll
Of the
I'll
horizon.
finish my presentation.
That's
I
not
think
the
the best
horizon.
thing-
That's his horizontal line he created with a tool.
Yeah, but that's
I'll
not even
continue.
at eye level. So the sun could go further
What's
down
not
as
at
it's
eye
moving
level?
away. It's dropping even further down the horizon.
What's not?
It
what's-
rises as you do, but it doesn't rise to, it's not perfect eye level because you've got height above the ground. So when you rise, you're going to always have some difference between where your feet and your eyes are, aren't you?
So I'll just continue on here anyway, guys. I think we're getting stuck around in circles.
No, we're not getting stuck. Tell me where the sun goes below what level. I don't understand what you were saying.
Well, if I go back to my picture just a minute.
Below the horizontal line you created with a tool?
The horizontal, the yellow line is the level line, horizontal from my position where I am observing. So perpendicular to down, it's
you
my
up in the
yellow
air or
line.
on the
Standing on the
ground?
ground, which is about 15 meters high.
So have you taken into account that, the 15 meters, all the...
Yes, of
Because the
course. If I
horizon is
can
the
finish
ground.
my presentation, then this will be explained further. So we got to here where I was describing how the ground appears to rise to eye level because this angle changes. I've drawn a blue line there, which is something, a similar stick, long way away. Then the bottom of it will appear at this shallow angle with the blue line. Okay with that?
I'm not sure I understand, but just continue.
No, dear, oh dear. Can you see
You're
the
saying
three
that blue
green
what
line
do you
is
mean?
going to the bottom of a one of these purple sticks way off in the distance. Is
Yeah,
that what you're saying?
Yeah,
Okay.
right?
All right.
Yes,
Okay, I understand your diagram. Go ahead.
right. Now, we'll skip this for the moment because I've just now tried to do just a different concept, an orthogonal view, which is a little bit to scale. So this stick man and this little shed is 15 feet apart in this scale if he's 6 foot tall. If they get 30 feet apart, you can start to see how things start to get smaller. 60 feet apart. And I've just had to enhance it because otherwise my stick man would disappear because of the change in angular resolution. 480 feet apart at this scale, they become small.
Is
just
this
like
how they would
in
look to us?
perspective.
Is that what you're saying? This is how they would look to us?
No, not exactly, because our vision is a bit more higher resolution than this screen.
But in relation
But-
to each other, you think this is how they would look? Because they would
In
obviously
relation
get closer
to each
together.
other, this is the angle between the angle that's of that shed, for instance, from this guy. That is the angle that you would see in reality, 480 feet apart. And so if I go now 1,920 feet, it's just a tiny dot. So this is not even a long distance.
Uh-huh.
So if you were to go further and further away, then that would become so small you couldn't tell the top of the shed from the bottom, and that's the
So
gap.
would the top of that shed be lower than the first shed that you drew?
No, it's all this. It doesn't change its position.
No,
It's a physical.
You're right. You're right.
Perspective.
No, it's not lower in perspective. It's just smaller.
Okay, so this is all this diagrams are supposed to show is that
Yeah,
things
it's a
get
smaller-
smaller
oh
as
my
they go away
God.
from us. Is that right?
That's an orthogonal view of things getting smaller as they go away from us. You don't need a perspective view to show that.
This makes
This is a perspective view. It's ridiculous. This is kindergarten perspective 101 taught by a
Put
freaking
all the
child.
shades in a row.
Of course, we have to do kindergarten perspective.
What point
Otherwise,
is
how are
this
you gonna
supposed to
understand?
prove, Critical? What point is the little stickman stuff supposed to prove?
Well, you said in your video the other day that you don't believe that this gap becomes zero. If I hang on, I'll see if I've got it. No, I don't know that I have.
I was questioning the assumption of whether or not the apparent horizon will always rise to eye level, because I haven't seen any experimental evidence or convincing evidence, period, that is what would happen. And that's a major assumption in a lot of people, the way a lot of people see the world and a lot of these analysis,
But
just
you
like your
also
sun
said
picture
that
analysis.
this shed would always have a physical presence in terms of a gap between the top and the bottom. And you said there would be a gap between that shed and your eye level. But as trying to show here, as your shed gets further away, you won't see that gap. So if we were to have
Oh, that's your point.
6
Okay.
foot, and then if it was like, hang on, I'll make it about 4 miles away.
I understand
Oops.
things get really, really small. You don't have to go through all this. I
Well,
get
when
that.
that's so if the shed is on the ground,
Uh-huh.
it becomes so small that you cannot tell the difference between the ground and the top of the shed. It's just one dot. So that's why the horizon appears to rise to eye level. So this here, for example, if that shed was nearly 4 miles away,
Can we move off of this, please?
the angle is 0.01, which is
Yeah, it's
less than
boring
the
as fuck.
resolution of the human eye. Therefore, the gap between the ground and the top of the shed, you can't even see it. So that's why the horizon would appear to rise to eye level.
But it doesn't literally rise to eye level if you're sighted on the top of that shed, does it? You can't sight the top of a shed and have the horizon rise up to eye
Flat
level,
Earth.
could you?
Why
So
not?
if you can't point your at two things at the same time with one finger, right?
I don't understand what you're trying to say.
Can you put? Oh shit! You would be. Okay, see how there is
I
two
don't
lines.
understand.
There's the dotted line, and there is the ground line.
They say us. We
You're-
don't understand.
you're
it. They
saying that
usually are the
those
ones saying,
two
I don't
lines
understand.
Go to the same.
I'm asking for
Point.
clarification. You know, there's nothing wrong with
If
that.
the ground it rises to eye level always, and I am in line with the top of that shed. My vision's in line with the top of that shed. How does the ground also come up to the same point as where my eyes are on the top of the shed?
It doesn't come up to the same point. It only appears to do so. It shrinks down to the size of 1 pixel, and you don't see it. You don't see it anymore. That's why they appear to be at the same place.
All right. What is your evidence that the ground always appears to rise up to eye level? Is this it, or is this just trying to understand what my diagram was saying? Because the point I was making in my diagram is very, very simple. So you're saying way before that happens, you won't be able to see it anyway.
You won't be able to see the shed anymore because the ground and your eye level become so small you can't resolve it.
Okay. All right.
So that's on a flat plane. That's just the way that it works.
I have a question for you, a thought experiment.
Well,
if you
you
don't
think
mind. Can
that
you guys
that
hear me
argument
clearly?
that you just made? Hold on, look, you missed it. He slipped in there. And he said that's how it would work on a flat plane. Yeah. So, what evidence do you have that the horizon will always rise to eye level, regardless of your altitude on a flat plane?
It doesn't.
Just by those doing the calculations of angular size. Tell me an elevation.
So it's
I'll work it out.
calculations. We're talking about the horizon, not how small objects appear in the distance. We're talking about the horizon, which only appears to rise to eye level. It only appears to rise to eye level. How do you know that that is consistent no matter how high you go up on a flat plane?
Because I can do the trig, okay?
So calculations.
It's
That's your proof.
Better to say that it
Well,
the horizon
why is it
rises
not
as
true?
you do.
Tell me what.
Because we're talking about
Tell me why it's
reality,
not true.
what you calculate. We already have enough problems and enough assumptions baked into your calculations and everything you do here. We're trying to get rid of assumptions.
This is not an assumption. This is mass geometry, Euclidean geometry. In this case, this is just the way the world works. This
Yeah,
is
and Euclidean geometry has proven you don't live on a ball.
no, it hasn't.
Horizontal-
And anyway,
level,
so let's just
horizontal.
say, for example, I don't know. We're talking.
No, we
about,
don't need to put more
if we-
numbers in here, Critical. Listen.
Well, no. You said something.
Okay,
you
so
said
that's
the
fine.
higher
If
the
you-
go,
if you've
the higher- how do
calculated
you
it,
know?
You've calculated what you expect to see due to perspective, right? Because in reality, the horizon never actually rises up to eye level. It just appears to because of the way we see. And what I'm asking you is, how do you know that on a flat plane, it will always appear to rise up to eye level? You can't calculate that. We're talking about what you see. And I don't believe your mathematics take everything that's involved with perspective and vision and optics into play, especially since some of the papers I read, they're still going back and forth trying to understand how we see.
Well, I've
Yeah.
just tried to explain in this session how the numbers calculate the numbers, how the perspective works, how something can appear to rise to eye level. And I don't know how to make it more simpler than that. But
can you understand we're saying you've put assumptions in there that we want actually verified? So instead of just keeping
And it
on
was
making
simple.
more calculations,
Simply
can you actually go
retarded.
out into reality and physically measure this drop of water or hump of water or whatever you say is going on with the water?
well, actually, yes, it's been done, but we have to come
No, I
to
can
the
show you a
basic.
27-mile canal that has the same horizontal level water top the whole way. No curve, no hump, no drop.
That's just your opinion now.
No,
when we
it's
did,
not.
when we did,
It's Euclidean
excuse me, when-
geometry and physical
no,
measurement.
water is
No,
not
no,
geometry.
Critical. No way, man.
Water
No, that's
is
not
not
an opinion.
geometry.
No, what we measure it with is geometry, you numpty.
And the measurement instruments do not lie. If they did lie,
Yeah,
the
and
whole
it's level
world would
and
be
horizontal
upside
the
down.
whole way. Level,
The-
horizontal, the whole 27 miles. Suez Canal.
Not. It is not. It's
It
been
is.
measured, right?
We've
Lake
measured
Pontchartrain's
it.
been measured.
It. No, that's
Lake Pontchartrain's
optical.
been measured.
Optical. If
It's
that's
been
your
measured.
critical, you live
Hold
on
on.
a fucking
It's
basketball,
been measured,
mate.
Guys,
physically
guys,
measured, no
guys.
optical.
Somebody's
All right.
spiraling.
Let's stop. Okay, just listen to me, Critical, and I think then we can be done with this. The assumptions that we talked about, the assumption that the horizon will always appear to rise to eye level on a flat plane, the assumption that you can use trigonometry, which I understand why you made that assumption, just straight trig based on sight angles, based on perspective sight angles for long distances, and you can calculate the position and then add your Earth curvature. Show us that that is correct for a distance of, say, 10 miles. You're not going to be able to show me another picture like this unless you're going to say something brand new and say this is how it works, because we're looking for actual evidence, validation in the real world.
There's the thing, Brandon, is that all
So,
the measurements. Critical thing, I have a question for you first.
It's a little hard to hear you,
Can
Data.
you you turn me up or no?
I got you almost all the way up.
I think it's your background.
Let me see how this sounds. Yeah, there's background noise too.
All right, I'll wait till later. But if you could just ask him quickly, if what you can hear is that if you take an arbitrary amount of observers at different elevations, all have an outward extended view. In each of the viewers, none of the ground is rising at any of them, but they all see outward farther. So can you have him explain that?
I'm not sure I understand the question well enough to explain it, Data. Maybe once you get to a better spot.
So every observer has an apparent junction of the sky and ground based on their elevation. If it's an apparent junction, meaning the sky and ground aren't touching, it's extended. The higher you go, you get an extended outward view. If the ground is only appearing to rise at each of the elevator's elevation heights, and they see farther out, that would be indicative of a flat extended plane because each horizon is based on your vision.
Yes, you're right. You mean people each higher than the other, each looking out, seeing their own apparent horizon.
Correct. So simultaneously, if let's say we had 3 cameras set up at 3 different height elevations, and it's arbitrary, we could have 50 cameras set up at different height elevations. In each of the observations, the ground is going to appear to rise, and at that appearance point, you're going to have a farther extended view. So if it's not rising to eye level, it's only apparent based on angular resolution, then it's a flat Euclidean plane for each elevator. The perspective of the human eye is what causes the convergence and the apparent curve.
Yep, spot on.
Right, so it's not an assumption.
Did you understand what he said, Critical?
Let me just talk first. I understand what he's trying to say. What he said was wrong. So,
what am I trying to say, Critical Think? Please recite back my argument. Thank you.
Your argument is that the horizon moves as you go further up. This is a property of the globe. This is not a property of the flat Earth. The flat Earth, the horizon.
That's not my argument. That's not my argument. Would you like me to repeat myself? That's not my argument. Would you like me to? Well, you don't seem to get it. Would you like me to repeat it again for you so you can recite it back so you understand my position? Or are you going to add your own things in? Would you like me to repeat, or are you going to add things in?
Your position is false. Your position is false to begin with.
Again, recite my position, please, before you add in your opinion.
Well, start again because I've forgotten what it was. I just know that you just said things which are false.
You know that it's false, but you know that it's false, but then you forgot about it. Listen,
come on,
dude,
give me a break here. Just repeat it and don't be stupid.
You just criticized me saying that you knew it, but then you don't know it. Now you forget. You want me to repeat it.
Can you just get on with the question?
Just rephrase it. It's not a question. It's an observation, a thought experiment for you, and I want your response on it. If it is arbitrary, the amount of observers at one position. So let's say we have 30 observers,
What's
all
arbitrary?
observing the number of observers here. Okay. It could be 3 observers simultaneously at different heights. It could be 40 observers simultaneously at different heights. Each observer sees an apparent junction based on their vision. Their vision sees the ground.
Is not apparent.
Let me finish. Each observer sees the ground to rise at different elevations. The ground isn't rising for each observer. It only appears to. So if it's only appearing to rise at different each elevations, what land is that possible on?
So if it's only rising, what?
Yeah.
It's
very easy to think about. It's very easy to think about. I don't understand why you're having difficulty.
Because it's nonsensical. That's why. Now.
So wait. You say it's nonsensical. So hold on. You said it's nonsensical. So listen. Does the ground rise for any of the observers, or does it appear to rise for all the observers?
The ground appears to rise.
So how's it nonsensical in my statement?
Well, the statement. What's your point? I don't get your point.
Power on a flat plane.
Oh my God!
Impossible on a flat plane.
All right.
Your brain dead, bud. Sorry, buddy.
We're
Your brain
wrapping
dead.
this up in about 5
It's
minutes. So
Only
make your
possible on a flat plane.
let's go.
No,
to
the
final
horizon
thoughts.
must always rise to eye level on a flat plane.
Says
But it
who?
doesn't. Listen,
Says
it
what evidence?
appears
Hold
to
on,
rise.
Beta. We're gonna wrap this up, man. This is going nowhere. So go ahead and make any final
this is
comments that
pointless.
you want. Critical think, and we'll give other people a chance to the ones that have been
Yeah, all right.
active in the
Well,
conversation too.
So just want to leave with this: a water level pointing up into the clouds. I'm not going to say much more about that. We've been through all of this stuff. Thanks for giving me the opportunity to talk. It is incredibly frustrating, of course, for all people, I suppose. But I see that there's difficulty in agreeing on basic geometric and physical concepts. So I'm not really sure where to go from there, but thanks anyway.
Okay, well, I appreciate it. Thanks for coming in, Critical Think, and giving us something to look at and talk about. Appreciate it. Yeah, there is fundamental disagreements because I think that you have assumptions baked in that make all the difference in the world. And could you make you think that you live on a giant ball if those assumptions are incorrect? And when I ask for the validation, the experimental validation, all I get is you can't because you live on a ball. That's not cutting it for me. I don't just go willy-nilly through life believing things because you showed it to me on a piece of paper and insisted that calculations and that Euclidean geometry and perspective sight angles work the way that you do. So thank you again, though. Appreciate it. You're welcome anytime. Travis, you were pretty active. Do you want to any final thoughts on this?
The only thing that I would say is, well, two things. The first thing is I would ask Critical to consider whether or not the apparent size of the sun would change his interpretation. Or, as I asked him quite early on in this conversation, do you actually believe you're seeing the physical sun in that photograph? Lower, I don't care, as long as you have different results. Now, my prediction is you will have. So my question is, when you are able to do this, what will having different results do to your conclusion?
So, and what will the different results will show that refraction varies on a day-to-day basis, but it will always show that the sun goes below eye level.
Okay, so then that goes back to my initial question, which is, what makes you think that the apparent size of the sun is the actual physical dimensions of the sun at that moment?
The size of the sun as it appears in the sky, there is always about 0.5 arc seconds, I think it is. And that remains fairly constant. It does vary a little bit, but it's fairly constant throughout. And every time I take pictures, and I've measured it from photographs before. So what?
All right, we're getting
does
back
that
into a
answer the
debate
question?
here, guys, but
That's
Really
fine. That's fine. You asked me for my final thoughts on this, and I just had those two primary questions. That's fine.
okay, all right. Anybody else have any final page? You were in on that too. Final thoughts on that conversation? I see you come off mute, but I don't hear you. Lemon, looks like you were about to talk.
Basically it's looking down a hallway, the top and bottom half of vision sandwiched together and merge. Same thing would happen to the sun if the sun was, say, an object plastered to the ceiling. So eventually the angles are going to converge and merge into the eye level of the observer and just be too tight to make out a 2D object. And it'll appear to set bottom first.
Gotcha. Thanks, Lemon. Page?
Can you hear me now?
Yeah.
Sorry.
We got you.
This is why I think, see, these optical, these things, the photos, long distance photos and stuff are fantastic for showing people how far we can see, and that we can see a lot further than you should be able to on a ball. But we need to drag them into the actual geometry of the ground, because we can look at a 3D drawing on a flat bit of paper and it looks 3D to us because of how we see. So we really need to bring it back to the physical, able to be measured ground and water, not just optics. Yeah.
Yep, agreed. Okay, anybody else? No? All right, thanks again, Critical Think. We're going to start our Friendly Fire Friday. You're welcome to stick around, Critical Think, if you want.
Okay.
We got a little bit.
I'm going to have breakfast. Thanks.
All right, thanks, man. We our champion Brian Leakey is not in the house yet. I hope Brian is out there and is going to join soon. Looks like we've got, if everybody participated, 1, 2, 3, 4, 5, 6, 7, 8, 9. We need 8. Jimbo's on mute, so hopefully you guys can participate. We'll see how many we can get. I did want to make one note. Last night I showed a sunset video and accredited it to Bev Try Thinking. That video was actually taken by Bev's son. So just I had forgotten that, but I was reminded of that today. So the sunset video that I showed last night was taken by Bev's son. All right. So
beautiful sunset, man. Shout out to Bev and everything he's doing.
Yeah. All right. Let me get this stuff going. What do you guys think about that debate or conversation? Personally, I was very frustrated with it. What do you guys think?
Demonstrating over a flat plane how curve works. Priceless.
Yeah, that's what I thought too. Yeah, he's trying. They desperately need to use optics to show their curve, because that's where their curve comes from the way we see. So they will never want to actually physically measure it, because it's not physically there. It's only there inside our eyes.
I mean, if you look at any of the panels that I've given you in the past couple weeks, Brandon, right? I've given you 3 panels side by side. And in each of the panels, the distant topography 9 miles away has a different angular size every single time. Now, if I don't zoom in with my camera and see that half of that image is an inferior mirage, then it might be my assumption that that is an entirely physical object that I'm looking at. That is, the dimensions are accurate to its physical proportions, right? But I would be wrong. And then if I see, hold on real quick. And then if I see in one of the other panels, there's major compression, so that it's almost 3/4 the size, right? And instead of being the same or bigger, it's smaller. So all we have to do, Ruhif and everyone else, right, is understand that when you're increasing distance, you're simply increasing that variable that is going to distort the size of the thing that you're looking at, so that you can't say, well, where's half of it? How do you know half's gone? How do you know it's actually not doubled in size in an inferior mirage? Because at that distance, your naked eye can't see that.
Speaking of the eye, I don't know if you guys can hear me. A lot of these apparent angular formulations, like taking the degree of an object, dividing it by 360, timesing it by pi, timesing it by 2, and then timesing it by the distance, will get you the height of the object. So these are all formulations based off of circles that have nothing to do with the ball Earth that you're on. It has everything to do with the eye. So you just with a basic degree calculations in the distance, you can know the height of the object in the distance, regardless of Earth curvature.
Yeah, I thought it was interesting. You know, the thing that frustrates me so much is I don't think he understands what I'm asking for, because I seem to be saying the same thing over and over again. So I don't know if it's a failing on my part or not, but I'm just asking for
No,
those
he
base assumptions to
understands.
be validated.
He just knows he can't. So he wants you to accept the evidence that is acceptable for him. You know, he's happy to believe that the math, you know, the math being right means that it's Earth curve, so he wants you to be happy with that too.
Yeah, that makes sense.
Well, in fact, I think it's just in plain sight in reality, because you can navigate on a flat circle with the same dimensions as they give you as the ball. You can have a diameter, you can have a circumference on a flat circle the same, and use basic Euclidean to navigate over a flat circle just the same.
He's doing the old like Red's rhetoric. Math is reality. No, it's not.
Exactly.
Yeah, some of these guys get the impression that we want to take away their mathematical model, because they say, well, we use this for stuff. What are you going to give me instead? I say, well, you know, that's not keep using it. Keep using the math. We're trying to figure out what shape the Earth actually is. That's why we keep talking about reality. That's why we keep digging into your assumptions. That's why we keep asking you for experimental evidence, because we want to know what the Earth actually is.
Their math is perfect. They're just saying it's the wrong thing. What the math that they are using, they call Earth curve, when the math is actually happening inside our eyes. That's the difference. It's the explanation of the math. The math's correct. You know what I mean?
Yeah, exactly. Yeah. Okay, guys. Why don't we get started with this? I hope we got some players here. Flat Earth Data, I know you're in your car. Did you want to participate?
I might be. I have a full house here, and so no, I can't.
Okay.
It'll get too loud. And
No problem. Travis, you in?
Yeah, sure.
Cool. All right. Jeremy. Oh, I don't even need to ask.
Fuck yeah. Yeah, fuck yeah.
All right, Jeremy. Let's see here. Jimbo.
I missed. I was in the kitchen. What's the event?
Friendly Fire Friday.
And how does it work again?
We give you the same question. Yeah, good point. So what we do is we pose a question to two flat earthers. They each get to take a turn responding to the question, making a statement, their argument, whatever. And then at the end of that, the people in chat will vote for the winner.
Sounds good. I'm in.
Cool. Yeah, it's pretty fun. Paige, you in? Lemon.
Listen, I think we should get another woman in for Paige. I don't think she should go up against a man. That's not fair.
Sorry. I just started playing DayZ. Okay, I'll try. Yeah.
Yeah. Okay. Cool. It's just for fun. And Lemon.
There's a bit of echo going on.
I think that's maybe Paige's mic. Paige.
Sorry.
That's all right. Okay, Lemon, you in?
I thought I went back on mute. It's just taking a while. Sorry.
Lemon?
Sure.
Okay, cool. Rakia, sounds like you might be at the table. You want to participate? How about you, SE?
Sorry, having supper, bro.
Bob Dole. Bob, you in? I need one more person.
I'm here. I was in the web browser on the iPad, but I am here.
Okay, cool. Well, this is going to be interesting because we've got 6 people. So How do you do a bracket with 6 people? Anybody have any clue? Let's see here. We might have to have a losers bracket, maybe. I don't know.
Yeah, that'd be good. You got the first 2 losers go, and then whoever wins is the next bracket. Yeah.
Yeah, you want to do that? Okay, so I'll have to move these around then just to make this make sense. And I'll go to number 8. There we go. So that puts Travis v. Jeremy up first. You guys' names in alphabetical order, so it seems like you guys get stuck going first.
Gotcha. I thought you said 10.
All right, you guys ready?
Yeah, I'm ready.
Yeah.
Well, speaking of timely topics, let's have Travis go first and then Jeremy. Question 1. Does the horizon always rise to eye level? Why or why not?
No, the horizon does not always rise to eye level because the medium through which you are looking plays a dramatic role in the apparent appearance of that apparent location. That's all.
All right, thanks, Travis. Jeremy.
My bad. Is it my turn?
Yeah. Does the horizon always rise to eye level? Why or why not?
All right. It doesn't always rise to eye level, nor should it, because there's multiple optical effects, refraction and whatnot. But also, like if you're looking down a long hallway and you go up towards the ceiling, you're now seeing more of the floor, and if you go down towards the floor, you'll see more of the ceiling. So it would change accordingly. I think that's it.
Okay, that's it. All right, vote now. 1 for Travis.
That's
8 for Jeremy.
1 for Travis. 1 for Travis.
Yeah, 1 for Travis, 8 for Jeremy. Go ahead, get your votes in chat. We'll give them about a minute. Let me read a super chat, and then we can, whoever else wants to chip in on that question can chip in. Why kick a moo cow? Number 855. Thank you very much. Brandon just admitted that he does not have a 100% explanation for day on FE, night and day on FE. How can people take him seriously? Well, why kick a moo cow? The fact that I admit that I don't have a 100% explanation. I can't tell you how the sun works. I can't tell you how far the sun's light will go. I can't give you the specifics like that. Now, I can draw you out a sketch. I can tell you roughly how I think night and day work on a flat Earth, but we don't know everything that's going on up in the sky. Just don't know. So that's why I say that I can give you my opinion.
What you should say, Brandon, is that you do know that it doesn't work on a globe. The time zones don't work on a globe. For instance, if you have 2 points, the polar point and along the same longitude line, and at one point is at 45 degree and the pole's at 90 degree, there'll be a discrepancy between 10 a.m. and around 11:30 a.m. They won't tell the same time. They'll be off. So if you had like a sundial attached to this particular object, so one was at 90, one was at 45, the angles of the sun wouldn't be consistent on that one longitude line. This is demonstratable. So
China does okay with no time zones. All of China is one time zone, and it's huge. It should have.
Yeah, I'm just talking. I'll give you an example. In Canada here, if we were in Quebec or Ontario, we put let's say we put a Norman pole, like a straight pole in the ground there, it would cast a shadow. And then we were at the North Pole, it would cast a shadow there. Being that if the Earth was a ball, one would be at 90 degree gnomon and the other would be at a 45. If along the same longitude line, they wouldn't be accurate at a certain point. They wouldn't cast the same shadow, thereby not casting the same the same time. And that's not reality, right? Along the same longitude line on Earth, you usually have the same time zones.
Did we lose anything? I can't hear anything.
Now we're here.
No.
I
thought that would be a good chance.
I just said something.
I thought that'd be a good chance to go to the restroom, but you guys, it obviously wasn't timed very well.
You gotta play. You gotta play like a 7-minute song.
Yeah, right. Okay, so we have a winner. 3 votes for Travis, 1 for Jeremy. Yes, that's correct. 3 for Travis, 1 for Jeremy. Jeremy still has a second chance since we're going to do a loser's bracket, so all hope is not lost, Jeremy. Congratulations, Travis, on your win. All right,
I'll take it.
Hell yeah. There we go. Let's go to the next one. This one is Lemon and Paige. Lemon, you'll go first. Paige, you'll go second. Question 2. What is the best evidence that the U.S. moon missions were faked? What is the best evidence that the U.S. moon missions were faked? Lemon, you're up. You there, Lemon? Actually, I think we lost Paige too, so we'll just skip to the next one. Jimbo versus Bob. This isn't turning out so well tonight, is it? Question 3, Jimbo, you're going to be first.
They're all scared.
Bob second. Question 3, is there a pressure gradient in Earth's atmosphere? If so, what causes it? Jimbo, go.
Yes, there is, and it's caused by the vapor in the air. Normal air with no water in it has a certain pressure it exerts at about 960 millibars, and then our weather, barometers, other stuff, differences in altitude and temperature. How much water the air can actually hold is based on temperature. And the higher you go, the colder it is. The colder, the less water in the air, the less vapor pressure. Now, vapor pressure is really atmospheric pressure as we know it. That's all there is to it. Less water in the air, less pressure. An example is at 70 degrees in your home, nice air-conditioned air, there's 18 grams of water in a cubic meter of air. Now, if you go outside and it's 100 degrees, in that same air, there can be over 50 grams of water in that same cubic meter. So it does add weight.
So what you're saying, Jimbo, is that? So what you're saying, Jimbo, is that gravity.
Data. You're interrupting. You'll get a chance to pitch in after they go through it.
It's his response. Sorry, guy. I'm sorry.
No, that's okay, man. Were you done,
Yeah,
Jimbo?
well, just that, like, when NOAA does its predictions for weather and stuff, and it has to do calculations, they create an artificial ceiling, a volume, a space for the calculations. So they'll create an artificial dome, if you will, at 15,000 feet, 16,000 feet, all the way up to 75,000 feet, which is about the top of most thunderstorms. So, and again, the higher you go, the colder it is. At 15,000 feet, it starts to be sub-freezing. You can't go on a delta plane without winter gear above 15,000 feet. That's where it starts to freeze out completely. But basically, the vapor of the water in the air is what causes the water to have that extra pressure, mass, affect barometers, and the temperature changes give us our weather. High pressure, low pressure. Water is also the agent that transfers heat. We get our heat from the sun, but also from the water transferring it. So it's part of physics and part of the reality. But yes, there is definitely a lower pressure level with ascension, going higher up. But this is due to the water vapor. Less and less water, less and less pressure. That's it.
All right. Thanks, Jimbo. And Bob, you're up.
Can you repeat the question?
Yeah. Is there a pressure gradient in Earth's atmosphere? If so, what causes it?
No, there's not, because there is no such thing as an atmosphere. The air around us does not take a spherical shape, and anyone who thinks that it does is either an idiot or ignorant or both.
All right. Thank you, Bob. Go ahead and vote. 3 for Jimbo, 6 for Bob. 3 for Jimbo, 6 for Bob. Data, you had some thoughts on this question. Is there a pressure gradient in Earth's atmosphere? If so, what causes it? Or anybody else? The floor is open. Well, people vote.
Well, Jimbo basically established it with the cooler temperature above us blanketing us, removing the so-called, not removing personally, but the temperature would make the water in the air condense and heavier, and therefore, you know. So I got a little bit of chaos back here. I can't.
Yeah,
I can't
it's great.
put my thoughts to fruition.
What song are they singing, Data?
Girls, go ahead and sing the song. Everybody's listening. Go ahead, sing the song.
Bananas in pajamas, we will kill your hair.
Wow, bananas in pajamas. That's a vintage. That's old school.
It is. They like bringing it up and laughing at each other over it.
Bananas in pajamas. La, la, la,
Yeah.
la, la.
Yeah, they were big fans of it when they were kids, right? Or younger children.
Okay. Anybody else got any thoughts on that? It's like the votes are coming in. 5 for Jimbo. Jimbo Skunk Bob. 5-0. Nice job, Jimbo.
Eek, I mumbled.
All right, next question. Let's see. We lost Lemon and Paige. Oh, Lemon's back. Lemon, you won by default. Congratulations. I think this is going to go quick tonight. So it'll be you and Travis versus Jeremy and Jimbo. Not much of a bracket tonight, but oh well, we'll deal with it. All right. So we're going to go to Travis and Lemon. Travis, you'll go first. Lemon second. The question is, how do you explain satellites? What are they and how do they stay in the sky?
Yeah, so since I've only ever looked into this in a cursory fashion, I'm going to deny that satellites exist in an environment where there is orbital mechanics, so that the observations, well, the evidence that I've seen in video where they have large mylar or large balloons affixed to these satellites, that would be my explanation as to how they reach different altitudes. And what was the other part of the question?
What are
Or was
they
that just
and
it?
how do they stay in the sky? How do you explain satellites? What are they and how do they stay in the sky?
Oh, okay. Well, I get that's what they are. So satellites, if they're created for making video and taking readings of any sort, either through video or barometric or whatnot, that's what they're doing. That's what they are. And how they do it is that they are suspended by a balloon, large balloon that's able to carry that payload. That's it.
Cool. And then it goes to Lemon. Lemon, what do you think about satellites? No Lemon? Oh, that's...
Woohoo! Default!
No. Right at the last second. How do you explain satellites? What are they and how do they stay in the sky?
Sorry about that. Attached to balloons. The only thing about satellites that is called into question necessarily is the gravity mechanism to slingshot it around the Earth. It could catch ionic wind, be a balloon, be in a plane, a drone. It may not even necessarily need to be a contraption. We have ionospheric bounce, so I contend that it's probably the ionodome. So these satellites may just be areas where they're reflecting signals off of the dome or whatever. But there's a bunch of different possibilities without something being slingshot over the globe due to globe gravity.
Okay. Fair enough. Get your vote in. 1 for Travis, 5 for Lemon. 1 for Travis, 5 for Lemon. And anybody have any thoughts on satellites?
Yeah, I think if 95% of data and information goes through fiber optic tubes under the ocean, and a lot of it is towers too, I mean, what's they're calling satellites is, I best mostly military stuff for, spying on people and stuff, and just saying it's all broadcast TV and shit is just a ruse to cover, their spying. But even here, okay, I can go down this street and take pictures of satellite dishes pointed directly into people's bedrooms and against their buildings. And they're angled to the tower in Quebec. So these satellite dishes are pointed right at buildings that are facing opposite this transmission tower and angled to, capture the signal from it. They're not pointed at no satellite nowhere. And I got a half a dozen on this street just like it. Big old building right in front of them. They're mounted, not even 40 feet, less than 30 feet from the building. And they're getting a reflected radio signal and, color chroma signal from the mountain on their so-called satellite dish that's supposed to have line of sight to the satellites. Because if you go look up any satellite installation, they'll show you bushes and a big, that red circle with the red line through it. Do not, or a tree or buildings, because the satellite signals aren't supposed to come through buildings. But yet, not just this street. There are lots of places that the dishes, they're pointed north. They're not even freaking pointed south to Houston and where all these Telsats are supposed to be. It's ridiculous. And they claim that one slot, orbital mechanics, let's try that word. Mechanics, I have to push off stuff, be physical, levers, fulcrums, mechanics. Orbital mechanics, what are you pushing off? Really? Some invisible umbilical cord? An invisible tether you're calling gravity? Now, in this ISS or all of these machines, there's a problem, because when you spin in a circle around a central access point, you want to go off on a tangent, a straight line, if you're not being tied down. Now, in the ISS, they're supposed to be going 17,500 miles an hour. Well, they'd be stuck to the outside wall of that tin can they're in, because when you're going around a circle, you're forced to the outside. It's physics. It's the way it works. You can't be in a ship that's being held by gravity and going in a circular path, and the people inside it not be affected by gravity and be weightless. It's cuckoo. Gravity should affect everything. But no, it only affects their tin and metal, and they get to float in suspension.
Does seem like there's something else going on, right?
That's just wrong.
Yeah.
And again, like I say, if you're in a truck going on a straight road and you're in the back, you don't see what's going on. The truck turns a corner. Well, you're going to be plowed against the wall, right? Well, anytime, and as long as the truck is going around a full circle track, you're always going to be pushed to the outside wall. It's the force. If you're going around a center point in a circle, you better hold on.
Right.
But these jackasses, gravity's holding on to their ISS and they're shipping their metal, but they're floating in the middle of it.
Yeah, but what about the math,
Having
Jimbo?
gravity pockets? Yeah. Well, like I say, in reality, if you're spinning in a circle, you're forced to the outside wall. If there's no wall and nothing retaining you, you'll be thrown off a spinning object. Try getting on a merry-go-round and not holding on.
It's only going 17,000 miles an hour, so,
Yeah. Well, it's to the moon, at least. I think moon and back once a day. It's the equivalent distance.
That's how far the ISS goes?
Yeah, well, it's well over 280,000 they claim to orbit every 90 minutes.
Right. 17,000 miles an hour. I'm sure they'd give you some number for the centrifugal force or some crap, but
you've seen airplanes that have suffered metal fatigue and stress. There was one that flew island hopper from, Hawaii to the other islands there, Maui, whatever. But it had done, I guess, 20,000 or more takeoffs. Okay, now part of the plane sheared off near the wing where, well, there were passengers. One got sucked right out of the plane. And you can find that on YouTube. And look at metal stress and fatigue, and it's a big concern on airplanes and jets. Because often you can't see through rivets and fractures and steel and all these problems and stuff. But that's the reality of metal fatigue and other stuff. It's reality.
Right. What were
You
those?
can't build stuff and have it never break down or suffer from, stresses at joints and at bolts or welds. And give me a break.
What were
and
the-
they've got this cupola with little rubber gaskets that they can unscrew and screw windows open to outer space. You have one in your home, one of those little screw-type window openers, and before long, you hear the wind and that little gasket is all fucked up. That'd be all their air gone from one of them, one of those little seals.
What were those planes where they flew them so high and like the joints were like leaking or something? Do you remember that story?
The
Was that
SR-71.
The SR-71, right?
Yeah, there's a pilot named Brian, I forget what, and he was in a place boasting about flying over Arizona at, I forget, 70,000 feet, and being able to see the foot of the Canadian Rockies, all the way to the Rockies, and all the way to Los Angeles from over Arizona.
Yeah, it was actually 80,000 feet. It was the S-71 Blackbird. And yeah, he's he's documented claiming that it's like flying over a sheet of glass.
Yeah, well, when I first heard his story, I wrote to Mike Helmlich, and we verified some information and stuff. Then Mike put together a little video on these statements of this pilot, and did a little video for YouTube on it, and it got shared with Mark Sargent, or mirrored by Mark Sargent. It got well over 1 million views, and it's still posted, I guess, on Mark Sargent and other places. So that felt good. I helped to get a 1 million views on a flat Earth video.
That's cool. Okay, so we have a winner, but I got to go back and look because I sort of forgot who it was. Sorry about that. Let me see.
It
One,
would be
two.
Travis.
That is. I'm sorry, Travis. No, that is incorrect. 3 for Lemon, 1 for Travis. 3 for Lemon, 1 for Travis. Who was the second person that went to the loser bracket with Jeremy?
That last round was the travesty.
Was that Bob?
Right.
Me and Jimbo.
Oh yeah. Okay, all right. So yeah, that's who is next. Jimbo and Jeremy, and then whoever wins will be in the final with Lemon. Thank you.
I thought that you were having the two losers go. That would have been Bob. Bob lost against Jimbo.
Oh, my bad. Yeah.
No, Jimbo did go against Bob. Oh, Bob lost. Shit.
Correct.
I'm all screwed up now.
Yeah. Okay.
My bad.
No comment.
I don't even know what the hell's going on. Oh shit. So it was Bob versus Jeremy. The bracket wouldn't update, so I'm trying to do it by hand. Trying to do too many things at one time. Okay. That's too many people. Okay, so Jimbo versus Jeremy. Right? Does that sound right to you guys? I really fucked the bracket up.
And Jimbo lose against Lemon, or
No, Jimbo beat Bob.
I've been distracted.
Yeah, so it's Bob versus Jeremy then, right? Yes.
Okay.
That's what it is. Bob versus Jeremy. The loser bracket.
Bob, you want to go first? You want to go first, or you want me to go first, Bob? Okay, good talk. Go ahead, Brandon.
Okay, I guess you're going first. Question 5. If the Earth is flat, why is there a day and night? Where does the sun go during nighttime?
this is fucking tough right here. The sun goes into the horizon far away from you, and the light can no longer reach you. And that's how you have nighttime, because the light can't get to you anymore. Pretty much it. I mean,
Okay.
you have light hold on. You have attenuation of light. Light doesn't travel forever in atmosphere. We know this. It's called light attenuation of light. And what else? That's good. That's it.
All right. Bob, you there?
Yep, I'm here.
All right, you're up, man.
All right. The thing that is generally referred to as the sun, but has not been verifiably, credibly, repeatably proven to be the sun, moves away or appears to move away. The light from it does. Well, I shouldn't say the light from it does. It appears to move away either by motion or by some sort of visual mechanism, thereby causing or bringing about the darker time. But the thing that we refer to as the sun, we don't know if that actually is the source of the daylight. We just know that it comes along with the daylight and that it does light from itself.
All right, thank you. So vote 1 for Jeremy or 2 for Bob in the chat, and we'll see who takes it. Yeah, this was the question that what's his face was asking me just a minute ago. Why kick a moo cow?
I mean, the sun goes into the horizon. Once shit's past the horizon, you can't see it anymore.
Yeah, I think there is, the light. People think the sun's all powerful. Why does it have to be all powerful? Why are we assuming, other than the fact that they say it's 93 million miles away, that the sun's light would light up the entire Earth? Is there anything that would tell us that it should do that? That sunlight should go 25,000 miles or whatever it is?
We can't even actually prove that the sun is what makes daylight. We can only show that it seems to produce some light, not that it produces all daylight.
Yeah, good point.
Well, the fact that it heats is a contradiction too, because you don't grow stuff with a fire, you grow it with light. So if the sun was a fireball, it would be burning everything. And besides, heat rises.
I think you're onto something. The idea that it's a fireball 93 million miles away, or whatever the fuck they say it is, it's essentially they're telling us it's a fireball, right?
Yep, but fire burns things. It's definitely a light. And again, the heat that's radiated around us, we don't really know that comes from the sun. Again, water plays an important part in transferring heat. Evaporation on the oceans cools them down. It transfers energy too. A lot of electrical power, ionized, energy. The different strata, every foot you go above the ground is a higher potential energy. My gosh. In some places it's so high, if it's the right conditions, when some of these jet fighters fly, they get a blue plasma aura around them. They look like they're on fire, blue fire. It's not hot, or it'd melt the plane.
Right.
But yeah, the idea that light is heat, it's not necessarily.
Well, we have a winner.
There's
one college football game.
Oh, go ahead.
You introduce that energy source into where the pressure is the highest, nearest the ground, and you have more air being produced there. Then you have more heat, and as it rises, it gets colder and colder.
There is a rule, is that light is generated locally, that light is produced by a process called atomic absorption, followed by the secondary emission, a lowering of the valence electron, if you will, back down to its normal state. And when it does that, after being excited, it yields light. Light is
Yeah.
produced by the interaction of material and energy. An
They give us
overabundance
these.
of energy going through material, the thing will boil off light. It's just the way it is, like a filament. We pump more
Okay.
voltage and current through it than it can pass without, boiling some off. Then, you won't have a incandescent light. Raise the voltage, it starts boiling off and gives light. It's the interaction of energy and matter locally.
All right, we have a winner. It is Jeremy 4-3 over Bob. Congratulations, Jeremy. You're moving on to the. Let me see here how this is working.
Bull crap! Can't believe you're
Yeah, we're going to have a situation like Trump not wanting to give up the White House, You lose, accept it like a man.
Right. So somehow we ended up with 3. Okay, I see what we got to do. So next is Jimbo versus Lemon. Okay. Next question. Actually, before we go on to that, there was a super chat that came in for $5. Why kick a moo cow? Appreciate that. So you can't explain the sun or night and day, but we should believe you when it comes to the shape of the earth. No. Speaking for myself, I don't expect anybody to believe me when it comes to the shape of the earth. This is what
you shouldn't believe any human being when it comes to shape of the earth. You should go look at it for yourself.
This is what we like to talk about. We like to discuss it. We like to research it. We like to do firsthand observations, and we share the information, and we do a show for fun, basically. We're not looking to replace science or turn everybody into flat earthers. If you learn something from it, fantastic. If you think we're crazy and don't learn anything, don't pay attention. All right, next question. Okay, Lemon and Jimbo. Lemon, you'll go first this time. Question 6. Do EQ mounts prove or disprove one model of the Earth or the other? Why or why not?
I'm going to say no. If they can say that something is so big it can be round but look flat, they could say that about the course of the sun if it is a round circle over the flat earth as well. It's such a big round, circuit above the earth that it appears flat when followed by a mount. At that point, it would have curvature that wouldn't be noticed by the mount anyway as it circles overhead. So as far as I can tell, it could still work on a flat earth potentially if the sun's circuit is wide enough for it to rise and dip below the horizon anyway. So the equatorial mount at that point with the sun, moon, and the stars wouldn't really be proving much of anything.
Okay, thanks, Lemon. And Jimbo. Do EQ mounts prove or disprove one model of the Earth or the other? Why not?
That track the stars, the equimount thing, those they actually would tend to prove that the Earth is stationary, not necessarily flat or round. Once they're set up and set, if you even barely touch them, you got to reset them. So that proves the Earth's not moving or spinning. But that's all I know. They don't prove flat or round, but they definitely prove we're not moving. We're spinning. That's it.
All right, fair enough. So we'll go with 1 for Lemon, 2 for Jimbo. 1 for Lemon and 2 for Jimbo. This is one of the things that I get bugged about a lot. And one of our in-house ballers, WS, brings this up to me probably at least once a week and claims that EQ mounts prove that the Earth is a rotating ball because it has one axis. So what they say is because it spins around to follow the star, and the stars go around at 15 degrees per hour, then the Earth must be a ball. I point out the fact that when you use an EQ mount, the only thing that's moving is the EQ mount. And then you add in your imagination that the Earth is moving and that the EQ mount moves to target the stationary star. And they also add in that when the EQ mount is looking at the ground after the star or sun or moon has gone too far away to see into the horizon, however you want to say it, that it's still tracking that object. That's also in your imagination. If you look through the eyepiece when it is after sunset or after it goes on the horizon, you're going to see the ground. That's all you're going to see. So I don't know.
So how's it tracking something when it can't see it anymore? Good question.
Yeah, it's not. They just imagine it will. Of course, the star, if you create this thing to spin around and follow something as it comes up from the horizon, goes overhead and down into the horizon, like a plane. Imagine a plane going over you. It's going to go in that same kind of direction because of perspective.
All right, so I've never looked into this, but it just came to me right now to ask this question. So is it possible to set up an EQ mount in a different latitude and give it the inaccurate coordinates and then have it follow an imaginary star that's not there, but it'll still track it the same way it would as if you had put it in the right location?
Yeah, it should, yeah.
They also run into problems when the star nears the horizon. There's a little issue with the EQ mount.
Why do you ask that question, Travis? That's an interesting question.
Well, that's my response to WS, is that it's a program. Of course, it's going to operate the way the program is set up, right? It does simply because the sky appears to move in 15 degrees. You have one of two choices: either the sky is moving or the Earth is moving. But you're still measuring 15 degrees per hour. So, to me, my question would justify the fact that it's a program. It's not following anything physical or actual. You just simply put in these programmed calculations, and then the machine works.
Yeah, and they say that it uses only one axis, but there's a thing called auto guiding that actually guides it using the other axis. But I don't know how else you would design something to track something that goes across the sky from one horizon to another and overhead. A rotating pivot head, they say, well, it was designed for the rotating Earth. No, it wasn't. It was designed to follow something that goes in an arc above you. That's how it would design. How else would you design it? But
may I also mention, too, that it does an excellent job at keeping track of things in straight lines. Meanwhile, it's spinning crazy velocities, traveling through infinite space at 500,000 miles, but yet keeps a straight line. Okay.
yeah, good point. We've got 4 votes for Jimbo. Lemon, no votes. Jimbo is going to move on to face Jeremy. Right, Jeremy, you won that last one. So Jimbo versus Jeremy for the finals.
Yeah. You want to go first, Jimbo, or you want me to go first? All right, good talk. Let's go, Brandon.
All right, cool. Let me pick which question I want to do.
And make sure that Jimbo's still here.
All right, this is an interesting question. Jimbo, you still here? Jimbo.
Oh, I won. Have a good weekend.
Holy crap. Well, we'll let you answer the question, Jeremy. You have to at least answer it so you can be the champion.
All right.
Okay.
Maybe I'll come back. What do you got?
Question 11. Since the Earth is flat and we aren't floating through an endless sea of nothing, which I spelled wrong, where the hell are we and why are we here? Speculate and give us your thoughts.
Okay, I like this. I have two opinion options on this. One of them is we're in a computer program, a simulation, if you will. The second one is we're in petri dishes on a shelf in a warehouse somewhere with a lot of other petri dishes. Let's face it, if you could make this creation, you wouldn't just do it once. If humans could make this, we would be making millions of them and exploiting them or studying them or whatever. So Yeah, those are the two options I like to go with: petri dishes or simulation.
All right, cool, Jeremy. Jimbo, you back? We'll give him a minute. Anybody else got some thoughts on this? Where are we and why are we here?
I'll have to go with the Hebrew cosmology. On pillars on top of a watery deep, surrounded by waters above and below the firmament, under the heavenly throne of God. But we're not moving. We're on pillars on top of a watery deep, motionless and at rest.
Hold on. As to why we were here, I don't know if people caught it. I didn't realize that was part of the question, but my answer would be for the creator to either study or exploit us in some way, whatever. That's it.
How about it's a delusion put forth because we denied the evidence the first time? So you get a taste of what existence is like because we are from a different realm, so to speak, and we're put in this realm to learn. Instead of question the delusion, instead of question him, we can now learn through the process of why we're here, learn about the delusion and repent.
We were put here to be in relationship with God and to learn, why things have to be a certain way and learn the consequences of our actions before we go on to eternity.
La La Land.
What?
La La Land.
It is La La Land because there's no way to define exactly.
You're cutting out data.
We do know.
I'd love to hear your thoughts on this, Travis. I don't think I've ever heard you answer any question like this.
What the nature of reality is?
I guess you could paraphrase it like that, yeah.
Yeah. I mean, I tend to want to believe that I am my own man, that I'm not a simulation, or that I'm not some artificial intelligence for a creator to observe. So, I mean, basically, I trust my senses, sight, smell, touch, hearing, and all of that. What are we here for? I would say that we are here to learn and grow and develop, mature, prosper, benefit ourselves and be beneficial to others. I think that we have been misdirected by the powers that be, not to understand those things, not to understand the way our world really works, and so I'm in the process of trying to figure out how to break out of that matrix and start all over again. Try to enjoy the time that I've got left.
I like that answer, man. I think I feel much the same way. Actually, a little bit of Jeremy's, and I'm definitely with you, Travis, on trying to enjoy the time that we're here and figure out what's going on, how to live the best life, helping other people, that kind of thing. But I do also think that we're probably in a human farm, and that one day we'll all be called and they'll start all of it over again and wipe the face of the earth clean, forget a few things, and the next group of people will come along and start the same process over and over again. Maybe we're we're the meaty parts in their galactic soup or whatever. I don't know. I don't know why they need humans, but this place seems to be purposely created to produce as many humans as possible in as much space as possible, or in the least amount of space. So there you go. I'm half joking, but I do think we're in a human farm.
Here's the thing, Brandon, though, is that they did a calculation, and they estimated that the entire population can fit in the state of Texas. So the Earth is massive, and so I don't think it's possible to produce this ideology of the perfect utopia, the utopia of farming. And I think what happens is they're losing control because of the technology, the accessibility, the money, the system that's created. I think their pyramid structure is losing control. There's too many little pyramids popping up. So in that case, yeah, they might want to do a culling, but I don't think they'll get away. They'll try, but I think they'll fail.
Well, whoever created this place, if we are indeed in a human farm, and this is just one of those crazy ideas that I kick around my brain, I would imagine that they have the power to do whatever the hell they want, whenever the hell they want, and that they've got this system built to serve their needs in the most efficient way possible.
Well, they would be able to, if that was the case, they would be able to shut everything off, and they don't do that, right? They don't,
Might only take a group like the Bilderberg.
So like,
There he is.
People from every industry and media, and you've got a,
Oh, hold on.
little cartel you can organize worldwide.
Sorry, Data.
Well,
you
Jimbo,
can-
what's your answer so we can?
Hold on.
My bad.
Data, you kind of got stepped on there. I didn't hear the
What's
end
that?
of your thing, but
it's all good, man. My signal's kind of choppy anyway, so it's all good.
all right, cool. All right, yeah, Jimbo, I'm glad you're back, man. So Jeremy gave his answer. Here's the
I
question
got
for you.
pulled away, so I didn't even hear the question. I'm so sorry.
Oh, don't worry about it, man.
Take it again.
Yeah, no problem. You're in time. Question 11. Since the Earth is flat and we aren't floating through an endless sea of nothing, where the hell are we and why are we here? Speculate and give us your thoughts.
Well, for me, we're part of creation. This place was created, made, built, manufactured, whatever you want to call it. It's stationary, and it's our home. However big or, small we find out it to be, it's what it is. And it's certainly flat. It's not moving. It's not going nowhere. And we are definitely here. We're not imagining all this. We're not part of a projection or some type of 3D hologram. Very real physical world here. So everything we've been taught is like more or less, and we know it anyway, bullshit. So we still have a monumental task of, solving, or we might never resolve everything, but at least, understanding some truth about, the lies about geology, about, the Titans and the giants are history from the creator down to who we are and what we are now. And that's the real question, Part of it's about how we treat each other in this journey. And some of us, myself included, it's pretty shameful. Sometimes it reflects on how we actually treat ourselves. I think, flat earth and this whole debate is for people more about stepping back and just taking a look at themselves, not even the shape of the earth. By what you do, you see who you are. But again, we're here, we're on a creation. It was created by, the person we call God Almighty. And I think anything short of that is pretty much babble and lies to distract from that. That's about where I am.
Okay, thanks, Jimbo. Interesting. All right, well, let's get the final votes in. Be 1 for Jeremy, 2 for Jimbo. We'll let those come in for a minute. We already talked about it, but anybody got anything else going on this weekend, or new video they want to plug, or any subject they want to talk about?
Well, I wanted to talk about that observation, how to force the line using infrared and gyroscopes. Infrared technology, laser line of sight, just as a conceptual idea, just to see the thoughts and views on it by forcing the line, meaning if we use drone technology or gyro technology with infrared, you should be able to force a straight line in 3D space using line of sight technology. And if that was the case, over a distance of 500 meters or a mile per drone per contact, you'd be able to see at the 10th drone the physical drop of the Earth, meaning that you are forcing the line using infrared and gyroscopic technology. So I don't know if you understand what I'm saying. 10 drones forcing the line because it's in 3D space, it's independent of Earth curvature, you're using line of sight technology, straight lines to force the line, thereby revealing Earth curvature under.
Real quick, this line of sight technology, does it refract or no?
Well, usually if you're going to do any calculation, because they already have this, right? If you ever look at any of the drone shows, they already use infrared collision technology, which is straight lines. So if you want to talk about refraction, diffraction, according to a beam, yes, there's going to be a divergence of the beam. There are culmination fixes to provide straight line paths. Remember, the technology is designed to be line of sight, meaning line of sight.
Here's the thing. I think it's a good idea, Data. I wouldn't put my energy towards doing it just because it introduces a bunch of new variables. The line of sight technology, you got to make people have to know about the drones, how they work.
So well, I'll tell you how it works. The infrared. So drones right now already work for polar coordinates and Cartesian systems, 2-point coordinates. The infrared sonar that's at the bottom of every camera, any collision prevention drone, uses this infrared technology. Now, how a drone locks into position is through an infrared picture it takes from the bottom. It's an infrared picture that locks in. When the drone lines up with that image, it locks into place. It can do this just using infrared, no GPS needed. Also, with the infrared technology, you can actually tell the height of the object from the ground. Again, independent of GPS, independent of rotation and curvature, not needed. And it just works off of light. You can tell the height of the object. Now, in the same principle, line of sight technology, for instance, 5G transponders that's used in smart cities, used in, for instance, the technology used in cars, just like the tractor beam in an Audi. The tractor beam shoots a straight line of sight beam. This is necessary for the function of the traction beam, gentlemen. So they have to make sure that the beam is accurate, so it has to shoot straight. With the same in technology, alleviating any deviation of the beam, shorten the distance between the objects, stretch it over a period of time. It's called Starlink satellites. They already have it. It's a straight path, and technology exists. It would reveal the physical curvature of Earth over a distance. So forcing the line is as simple as having a gyro and line of sight technology.
Okay. Well, something to think about. You planning on?
I have thought of using drones. I have thought of using drones before, by just having one drone, and if you can make a drone fly straight, and just in a straight line, then that would be I feel like that would be a viable option. But
you need to force the line. In other words, listen, if people are being disingenuous here, it's really easy to tell. You want to have a straight line in 3D space. And the whole point of technology is to create a straight line in 3D space. This is the line of sight technology. It's the purpose of it, because the fastest connection between 2 points is a straight line. So if you're worried about deviation or refraction or diffraction, every laser, every wavelength of light is subjected to diffraction, subjected to refraction, all of it. But they have workarounds, so it's like a culminator, which is focusing the light. Different strength, different techniques that they use, and I don't know all of them. But the idea, gentlemen, is to be as accurate as possible in a straight path in 3D space. That's the point of the technology. If it's in 3D space, it has nothing to do with Earth curve. The line of sight itself is designed to shoot straight. And if this is the case, then it should reveal a physical body curving away from the line of sight. And we know it doesn't. You can look at tons of drone footage. The drones work off of polar coordinates or Cartesian. It's just 2 coordinate systems, X, Y. It ain't no curve, nothing. They don't think about it. You don't operate around it. Nothing.
Yeah. Okay. Hopefully the audience could hear that. You're really low, but that's all right. I could hear it. I got you turned up all the way. Okay. Let's see who the winner is. That's right. I'm supposed to be counting the votes here. I got 4 for Jimbo, 4 for Jimbo, 0 for Jeremy. Jimbo, congratulations, man. Nice work.
Congrats,
dude.
Jimbo.
You kicked some butt.
They don't like the thought of being in a simulation or a petri dish.
Yeah, no, probably not. Jimbo had a good answer.
Well, I have a question for you, Jeremy. Are you angry? Would you be angry if you found out that the Earth was enclosed and you can't go anywhere, and no matter what technology you had access to or money you had access to, you couldn't leave or discover anything more? Would you be mad?
I wouldn't be mad, no.
Do you think the elite are mad, or the people that, like, for instance, Admiral Byrd, if he was discovered certain things, I mean, he was told or found out you couldn't do certain things, you're either under instruction to do that, or you know not to do it. What would be the point of not limiting travel or limiting exploration? Like, what would be the point of it? To protect your safety? Like, why
Sorry, what would be the
travel? Yeah, why are they limiting travel then, right? If you're claiming you wouldn't be mad about the enclosure, then why would they prevent you from exploring? Why would they prevent you from just accessing wherever you want to go, right? They obviously want to control and have specific locations and limitations to what you can do. It sounds like somebody's pretty mad.
I couldn't hear what you said good. You got a lot of background noise.
Yeah, it is hard to hear you, Data. All right. Anyway, guys, anybody got anything else? I think we're going to close it out. No? All right. We'll do a quick round of final thoughts. Travis, any final thoughts? No? Jeremy?
Yeah, this guy exposed Antarctica. This guy was doing a show on the Potato Channel earlier called Expose Antarctica. And I was listening to it. I didn't get to finish, but it sounded really interesting. Maybe, check that out. Because I do think Antarctica would play a part in all this, could reveal some truth for us. So maybe check out his channel, Expose Antarctica.
Yeah, let me bring that up real quick. Tell us what video you're talking about.
Yeah, hit him with the link.
Expose
I don't know. He
Antarctica.
was making it while I was there.
Yeah, okay. There's his channel, Expose Antarctica. I'm already subscribed. Cool.
Yeah.
Jimbo, any final thoughts?
Yep, it's flat, but try to be good to yourselves and each other. And keep in mind, God and the angels are watching.
Cool. Thanks, Jimbo. Bob, final thoughts?
Yeah, I'm good. I'll pass.
Cool, man. All right. Thanks, guys. We will have a good weekend. We'll talk to you later. I'll probably be back. Yo. Okay. Well, that was a really weird show. Had a weird vibe the entire show. Anyway. See the comments in the chat. Rufus St. Hubbins. I feel like the community needs to address Fight the Flat Earth's latest video. It needs to be debunked or causes some problems. What's going on with Fight the Flat Earth? Oh boy. Let's see. Flat Earth scientists face defeat. Okay, is this the one that you're talking about, Rufus? I take that it is. I guess I will check it out and see if there's anything worthwhile in there. Flat Earth scientists face defeat. I gotta be honest, I don't have great hopes for what I'm gonna find in there, but thanks for the tip. Let's see what else is going on. What are you guys talking about? I hit a couple people on the channel just because I got tired of their shit. One in particular goes around and lies about me constantly, and anybody else, and I've just had enough of it over the years. It's getting old. So I'm done with that. Anyway, you guys have a good night. Gary, Wally, I haven't watched your video. I will watch it. And I know you think that you can tell the shape of the ground by looking up at the stars. I'm skeptical. So we'll see what kind of assumptions you got on there. Maybe I'll respond. Curious to see if you did get any flat earth participants. I wanted to participate, but I never got around to going out and taking a picture, unfortunately. Let's see. It's the rocket issue. Pete and Pete. It leads a lot of credence to the legitimacy of rockets in orbit. Huh. Okay. Rockets in orbit. Well, I don't necessarily... Is that a problem for flat Earth? I know if you define an orbit as going around the Earth, it's a problem. But no one's saying you can't shoot rockets up. Because we see that happen. You shoot a rocket up. Release a payload. Maybe it releases one of those balloons. I don't know. They always look like they're going the wrong direction to me. But I'll take a look. Maybe these guys were just wrong about their argument. Anyway, okay. Oh, anyway, well, guys, I'm tired. I'm going to go eat some dinner. I'll see you on Monday. Probably could use a couple days to get refreshed. And hopefully we'll have some fun stuff coming up for you next week. Everybody have a good weekend. And thanks for watching the show. Bye.